may well have come across this sign before in maths. It means the square root of. Basically, what number, when multiplied by itself, or squared, will make this number. For example, the square root of 9 is 3, because 3 squared, or 3 times 3, will make 9. The same goes for 4 times 4 equals 16, therefore the square root of 16 equals 4, and 16 times 16 equals 256. Therefore the root of 256 is 16. However, it's not always that simple. Not every number has a whole number as its square root. Take the square root of 2 for example. We know it must lie somewhere between 1 and 2, but it's almost impossible to work out exactly what number will multiply by itself to make 2. A number like this is called a surd. All surds are irrational, meaning they can't be expressed as a fraction. So you can't convert the square root of 2 into a fraction, a number over another number. So if surds are irrational and can't be expressed as whole numbers or fractions, without turning them into decimals, how could we do maths with them? Well, there's a few rules you'll need to understand at A level. Firstly, like with any square roots, when you multiply a surd by itself, it becomes the whole number that is inside the square root sign. So for example, the square root of 2 times the square root of 2 will make 2. Second, if a times b equals c, then root a times root b equals root c. That may sound a bit confusing, so here's a real number example. 3 times 5 makes 15, so the square root of 3 times the square root of 5 makes the square root of 15. Knowing this can be extremely useful working the other way. So for example, root 75 is equal to root 25 times root 3, because 25 times 3 makes 75. In a situation like this, we can simplify the surds even further, because the square root of 25 is a whole number. Therefore, because one of the factors of 75, 25, is a square number, we can simplify root 75 down to 5 root 3. That means 5 times the square root of 3. Here's another example. 200 is not a square number, which means we can't convert it into a whole integer, or a whole number. But you'll notice that 100 is a factor of 200, and 100 is a square number. Therefore, we can use our rule from before to work out that the root of 200 is equal to root 100 times root 2. Like with the last example, when root 25 was equal to 5, root 100 is equal to 10. Therefore, we can simplify root 200 down to 10 root 2. Adding and subtracting surds can be fairly easy if the same whole number is inside the square root sign. For example, root 5 plus root 5 makes 2 root 5, and 7 root 6 minus 2 root 6 will make 5 root 6. Now we're going to move on to something called rationalizing certs. This is when you have the surd on the denominator of a fraction. For example, 3 over root 5. How would you get rid of the surd from the denominator of the fraction? Well, this is how you do that. You multiply the fraction with the surd as the denominator by another fraction of that surd over that surd. So in this case, root 5 over root 5. You should know that when you multiply fractions, you multiply the numerator, or the top number, by the other numerator, and the denominator by the other denominator. And you should remember from rule 1 that when you multiply a surd by itself, it becomes the whole number that was inside the root sign. So in this case, the denominator will become 5. As you can see, we've successfully removed the surd from the bottom of the fraction, and the final result is 3 root 5 over 5. Let's try another example, but this time there will be a surd in the numerator as well. Well, this doesn't change the process. We still multiply it by a fraction of the denominator surd over the denominator surd. So we still multiply it by root 2 over root 2. This is because when rationalizing surds, which is what we're doing here, we're just trying to make the denominator a whole number, not necessarily the numerator. And the solution is 4 root 6 over root 2. If you're not quite sure where the root 6 comes from, it's because we've multiplied root 3 by root 2. And as you'll remember before, when you multiply a surd by another surd that's different, it becomes the root of the two whole numbers inside the surds multiplied. The 4 outside isn't affected. This is a much more difficult example to solve because there's two different surds on the denominator of the fraction. What we do here is again multiply it by a fraction, but unlike before, we're not just going to multiply it by one surd over the same surd. Both the numerator and the denominator of the fraction we multiply it by will be what's called the conjugate of this denominator. Essentially the same, but the sign is the opposite. So if it's a plus here, it will be a minus in the fraction, and vice versa. So in this case, the conjugate of root 5 plus root 2 is root 5 minus root 2. So that's what we put on both the top and the bottom of the fraction we're multiplying it by. The next line of the equation looks very complicated, but we'll take it a step at a time. The numerator of this new fraction we've created is a double bracket. So one bracket of a plus b multiplied by another bracket of a plus b. The denominator is also a double bracket in the same form, but we'll work through the numerator first. When solving double brackets, you follow the order first, outside, inside, last. That means you multiply the first number in both the brackets together. Then you multiply the two outside numbers. Then you multiply the two inside numbers. And then you multiply the two numbers that are last in each bracket. When multiplying the first numbers together in this example, we're multiplying 3 root 5 by root 5. You'll notice there we're multiplying root 5 by root 5, which makes 5. We then times that by the 3 and we get 15 as our first number on the numerator. Next, we'll do the outside numbers. In this example, we've got 3 root 5 multiplied by minus root 2. This is a bit more tricky, but you'll remember how to multiply two different surds together from our previous rule. Root 5 times minus root 2 will be minus root 10 because 2 times 5 equals 10. You'll notice root 5 is multiplied by 3, so the whole thing will be as well. So we end up with minus 3 root 10. The next number on the numerator will be minus root 10. This is because we're multiplying the two inside numbers together in the double bracket, which are root 5 and minus root 2, which gives us minus root 10. The final number on our numerator is going to be plus 2, because when we multiply minus root 2 and minus root 2 together, they become the whole number 2, and the two minus signs cancel out to make a positive. Now for the denominator. What's going to be the first number? Well, as you can see, it's 5, because we're simply multiplying together root 5 and root 5, the first numbers in both of the brackets on the denominator in the previous line of the equation. The next number is minus root 10, because again we're multiplying root 5 by minus root 2. The third number will be plus root 10, because now we're multiplying the inside numbers of the double brackets together, which are root 5 and root 2. The final number will be minus 2, because we're multiplying together the last numbers in each of the two brackets on the denominator in the previous line of the equation. And these two numbers are root 2 and minus root 2. Unfortunately, I've run out of space on my whiteboard. If you need to check the previous lines of working, you'll have to rewind the video a little bit. So what we've got the equation to so far is 15 minus 3 root 10 minus root 10 plus 2 over 5 minus root 10 plus root 10 minus 2. This may still look extremely complicated, but I promise we can make this simpler really easily. You don't have to do this step, but it can make it easier to see which numbers you're working with. All I've done is move the numbers around so that the whole numbers are together and the surds are together. So now we can add the whole numbers to each other and we can add the surds to each other because they're surds with the same whole number inside the square root sign. First, we'll work on the numerator. 15 plus 2 makes 17, so that will be the first number we put on the numerator. Next, negative 3 root 10 added to negative root 10 will make negative 4 root 10. Finally, we'll simplify the denominator by working out that 5 minus 2 will make 3, and negative root 10 plus root 10 will cancel out to 0, so the denominator will just be 3. This leaves our final answer as 17 minus 4 root 10 over 3. That may seem like a lot of working out for one question, and it kind of is, but with enough practice it can become almost second nature. Try going over some of the other topics with double bracket equations in, and you'll get far more used to the first outside inside last process. We'll now move on to a completely different part of the surds topic. Powers and brackets involving surds. Like this one, for example. Root 3 is inside a bracket, and that bracket is to the power of 4. By the way, my dad's hoovering upstairs. I hope you can't hear that too loudly. With this particular example, root 3 in brackets to the power of 4, there are actually two ways to solve it. The first is to simply write it out in full. Root 3 to the power of 4 means root 3 times root 3 times root 3 times root 3, which is the same as saying 3 times 3, which makes 9. The other way of solving this is to change the square root inside the bracket into a power, or an index. You should remember from the indices topic, if you've done that a square root of a number is the same as that number to the power of 1/2. So inside the bracket, you can change the root 3 to 3 to the power of 1/2. You should also remember from the indices topic that when there's one power inside the bracket and another power outside the bracket, you simply multiply the two powers together. So in this case, 1/2 times 4, which makes 2. So the final answer is 3 to the power of 2, which is 9. There are other parts of the topic of surds that I haven't covered yet, but you should now have a better understanding of what surds are, how to simplify and rationalise them, and how they behave when they're in brackets. Thank you for watching, and let me know if there are any important parts of the surds topic that I should also cover, or any other topics you'd like to see me talk about. By the way, I'm only doing A-levels in maths, biology, chemistry and German, so if it's outside of those 4 subjects, then I'm probably not qualified to talk about it. There are way better speakers on all 4 of those subjects as well here on YouTube, so I don't actually know why you're listening to me, but I'm happy that you are. Thank you for watching. Goodbye.